Hello there. Today we're going to go over linear versus exponential relationships, and I'm also going to throw in a little bit of interest. So let's talk about the distinction between linear and exponential. And it's pretty simple. Linear just means that whatever it is that we're talking about, whether it's money or anything else, that the way that it increases or decreases is by the same amount every month, year, it doesn't matter what the time span is, but it's always increasing or decreasing by the same amount. So an example would be if we start out, we start a bank account and every month we put in $10. Okay, that is a linear relationship, and the balance in the account would be increasing linearly. Now, if it's an exponential relationship, that is going to go up or down at a much greater rate. And you can see that because there'll be an exponent, right? So it might be like a typical, we'll do a problem like this later, but a typical banking equation might look like you put in $100 into a bank account and you get a certain rate of interest. Let's say it's 3% interest, and for per year. So let's say T is years. That T is typically years in these situations. So whenever you see an exponent, that means it's going to be an exponential relationship. So rather than your bank account balance going up by, let's say, $10 a month, 1 month it'll go, well, actually, let's just work it out. Okay, so let's say we have $100 to start with, and we get 3% interest. 3% of 100 is 3. So in our first year, we're going to end up with $103. Well, the second year, we're also getting 3% interest. 3% of 103, if we work that out, is going to be 9. And then it's going to be $3.09. So it's not going up by that much, but it's more than the $3. So we're going to get 106.09 in the second year. So here, this is the first year, and here, this is the balance of the second year. Okay, so first we start, use a different color here. We start off with adding $3, and then we add $3.09. This is an exponential relationship because it's not going up by the same amount every month, but by a larger amount every month. Okay, so let's go to work with some of these questions in the test. All right, so let's go to test 1, section 4, number 5. And we're also going to do 37 and 38. So I'll just write that down here. Okay, now number 5 says, which of the following graphs best shows a strong negative association between D and T? Now, a strong negative association, it's not really saying whether it's linear or exponential, but I wanted to include that in here because I think it relates. All right. And you'll find this is going to be pretty easy, I think. Okay, so we have A with a bunch of dots. Okay, it's just all over the place. There is maybe a slight negative association, meaning a negative slope, but it's really, these dots are almost circular. There's probably actually a couple out here too. And you know what? I should probably just go over really briefly. A slope that is positive looks like this, and a slope that is negative looks like this. You should know these two. So when it says a strong negative association, we're looking for this one, right? A negative slope. Okay, so now we can see that although A has a negative slope, is it strong? I'm not sure. We could leave it in. All right, B almost looks like a smile in a way. It's I wouldn't say it's very strong, and it's certainly not negative. If anything, it's slightly positive. So I would get rid of B right away. And C, we can see it really is an extremely positive association. It really looks more like this one. So we can get rid of C. And D is, well, it's definitely looking negative. Now the question is it more negative? Because we want a strong negative association. I think D looks stronger than A. A is a little bit more, I don't know, a little bit more circular, and D has a stronger relationship. D is going to be the answer. Now, let's flip our pages over to the very end of the test, 37 and 38. And I'm going to clear the decks here, and we'll begin. So it starts out by saying Jessica opens a bank account. So this is the interest question I wanted to cover in this video. That earns 2% interest. So we're going to write 2% int. That compounds annually. Her initial deposit was $100, and we're going to write that down as well. And she uses the expression 100x to the t. Right? You should get to know this expression that is going to be standard in any exponential relationship. And this finds the value of the entire account after t years. So t is years, and that is also standard. 37 says, what's the value of x? Well, we already have the $100 deposit covered here. And we already said that t is the number of years. So x has to be the interest. So most people, or many people, would say, well, if x is the interest, that's 2%. And the way you write 2% is in a decimal form is 0.02. So x should be 0.02. However, they asked you for, well, they said that this finds the value of the account. So the entire account, not just the interest earned. That includes the initial $100 deposit. So instead of being 0.02, it needs to include that $100 deposit. So this one actually represents 100% of the initial account value, which is in this case $100, plus the 2% interest on top of that. All right, now we go to number 38, and it says Jessica's friend Tyshawn found an account that earns 2.5%. So now we have 2.5% interest compounded annually. Tyshawn made an initial deposit of $100, so it's the same deposit as Jessica made. And let's see, they made the deposit at the same time. After 10 years, how much more money will Tyshawn's initial deposit have earned than Jessica's initial deposit? And then they tell us to round the answer when we're done. Okay, so let's just make a distinction here. This is going to be Jessica up here, who was earning 2%. And this is going to be Tyshawn down here, who's earning 2.5. And we're going to be using this expression here to figure it out. Okay, so we've got, let's do Jessica first. We've got 100. X is going to be our 2%. Okay, now because we have 10 years, right? And you might say, well, how come we're not using the 1.02? And it's because of the question. The question is saying, how much money will each account earn in interest? It's not saying how much is the total value of the account. And that makes all the difference in the world. Now, we could do it that way. You could say, how much more money will they have earned? You could do, if you put the 1.02 in, it wouldn't be wrong. What you would just need to do at the end is subtract them, because you'd get the total amount of the account value. Okay, let me just show you if you did it this way. If you work this all out, and this is the calculator section, so you can use that, you would get 121.899. And I'm bringing this out, the decimals out to the third place, because then we're going to round it down to dollars and cents, and we want 2 cents. The two, not 2 cents, but the 2 places for the cents. Okay, so that's that. And then we do the same thing with Tyshawn. We get 100, but he is 1.025 for 10 years, and we get 128.008. Now, if we were to subtract these two numbers, we would end up with 6.11, which is our answer. It's 6.11 something rounded. All right, now, but I do want to just say here, use a different color. You could have not used these ones, and then you would have just gotten the answer. You would have gotten the same answer. All right, let's move on to, let's get a line here. All right, we're going to go to test 2. Yeah. Whoops. Okay, test 2, section 3, number 14. And it says a radioactive substance decays at an annual rate of 13%. So it decays at 13%. If the initial amount of the substance is 325 grams, you write that down. 325 grams is what we start with. Which of the following functions F models the remaining amount of the substance in grams T years later? So we still are going up to this kind of basic expression. Instead of putting $100 here at first, because that was for this particular problem with the $100 deposit, we're starting with 325. So we have 325, and then we have, as we did up in the banking problem, we have our percentage here, and then the number of years. And they give us that. They say T years later. So T, again, is the number of years. So we have a percent. Now, before we even go further, let's look at the answers. Okay, we need to have something with the 325, or the initial amount, outside of the parentheses. And we can see that C and D do not fit that criteria. So we can cross them out. We're looking at A and B. Now, if we look at B, it has the 0.13 in the parentheses, which relates to the 13%, which makes it very appealing. However, you have to make sure to read the question. The question is asking for the remaining amount. And in fact, when you first read the question, you should underline that or circle it. Make it a big deal. This is what we're solving for. This is what they give us. They're not the same thing. So if we start with, let's say, 100%, since we're dealing with percent, and it decays at 13%, what is left is 87%. The remaining amount is 87%. So that's what we want in here. That is our answer right here. And that, my friend, is A. Okay. So let's see what else might be interesting. Okay. Yeah. Okay. Let's go to, I'm not going to anything. I'm going to just clear the decks. And I want to talk about another way that they could present a linear versus exponential question. And let's go back to the banking, right? So let's say you have there we go, $100 in your account. And every month you make a $10 deposit per month. Well, we already know this is linear. It's going up by $10 every month. But what if they said you make every month a deposit of 5% of the initial deposit? Well, 5% of the initial deposit is 5% of $100. which is the same thing as $5, which means it's going up $5 every month. It's still linear. What if they said 5% of the, I'm going to call it ID, initial deposit, plus 15 more dollars? It's still the same amount every month. It's still linear. Now, what if they said, we're going to put in 5% of the current balance? Well, the current balance goes up every month. So 5% of a changing number is always going to be different. Here is your exponential. Meaning 5% of an increasing number is going to get you an increasingly higher deposit every month. Okay, this is the one. That's the exponential. Okay. Is there anything else I want to say? Yes, there's one more thing that I've seen come up before that students sometimes get confused by. So let's say there is a chart and we have numbers increasing from 10 to 100 to 1,000 to 10,000. Some people say, oh, well, this is linear because we're just add a zero and we're doing the same thing from here to here to here. However, it's not, that's not how you work it. It's that you're adding or subtracting the same amount. So from here to here, it's 90. But from here, it's from 100 to 1,000, it's 900. And from 1,000 to 10,000, it's 9,000 that you're adding. So you're adding increasing amounts to get from one number to the next. So this is definitely exponential. Okay, my friend, that's all I've got for you. Take care. I'll see you next time.